Hello friends, welcome back to my channel Maths by Samit Deshmukh. So in this video we are discussing application of matrices. So here we are studying two important application of matrices to solve the linear equation in two variable. In your earlier classes also, means in 10th standard also, you have seen how to solve the linear equation in two variable applying 2-3 method. One is elimination, one is substitution, one is cross multiplication, and one is, even you may remember that, Cramer's rule also, isn't it? Now using matrices we are discussing how to solve the linear equation. So here we have considered two equations with two variables, isn't it? So we are studying about how to solve the linear equation with three variable also using what? Matrices. And since we are applying matrices, that's why it is called as application of matrices. So first, whatever may be the two equations are given to us, collect the constant terms on what? Right hand side. On this side collect the terms of x and y, and on another side collect the constant terms, isn't it? If the equations are written in this form, then this equation can be written in matrix form as. So let us write down this equation in the matrix form. So while writing the equation in the matrix form, observe the first equation very carefully. Here what is coefficient of x? That is a1. Then write down here coefficient of x, then write down coefficient of y, that is b1. In this matrix collect the variables are nothing but what? X and y are the variable, and here write down the constant term. On this side write down the constant term from first equation. In the second row, here write down coefficient of x from second equation, then write down coefficient of y from second equation, and on this side write down what? Constant term in this equation. If we are writing this equation in this form, means using matrix, if we are representing this equation, that's why this is called as matrix form of the given equation. Now again, if we are solving this equation, we will get the same linear equation. Just try to understand here. So if I am taking multiplication of these two matrices, while taking multiplication we are multiplying by row to what? Column. So multiply by first row to first column. What will get? A1 into x will be a1x, b1 into y will be equal to b1y. Now multiply by second row to this column. What will get? a2x plus b2y, a2x plus b2y, and on that side keep the matrix whose elements are c1 and c2 as it is. Just simply we have taken multiplication of these two matrices. Now here we can observe that these two matrices are what? Equal matrices, and we know that if two matrices are equal, corresponding elements are also equal. Means what is the value of a1x plus b1y is equal to what? C1. So we will get first equation, and a2x plus b2y will be equal to what? C2. Means we will get second equation. Means after simplifying this matrix form, we will get the same equation. Its meaning is that this equation can be represented in this form, because after solving it we are getting same equation, and this representation is called as what? Matrix form of the given equation. So if we are representing given equation in the matrix form, you will get first mark. Okay, so it is very easy to get this first mark, isn't it? So now we are discussing the method to solve the equation. One of the method is what? Inversion. But to apply this method, first we have to write down the given equation in matrix form. Once these equations are written in this matrix form, then denote the first matrix by A. So let us denote first matrix by A, whose elements are A1, B1, A2, B2. Then second matrix I am denoting by X, where element of this matrix are X, Y, and denote this matrix by C or B. Denote by any capital letter, better way denote it by B, whose elements are C1, C2. So this implies that this equation will become, this first matrix we have denoted by A, this matrix we have denoted by X, and this matrix we have denoted by what? B. So whatever the equation we have got here, denote this equation by equation number first. Once this matrix form is known to us, after getting this first equation, our aim is to find out inverse of this matrix. Inverse of which matrix? A. And to find out inverse of a matrix, we will have three choices: either apply adjoint method, or row transformation, or column transformation. Here we are able to apply any method to find out inverse of this matrix. Once the inverse is known to us, then consider the same equation. So from equation number first, from equation first. What is the equation first? Ax is equals to b. So multiply both side by A inverse. So A inverse into Ax is equal to A inverse into b. So on this side, A into A inverse will be equal to what? Identity. We know that A inverse into A is identity. Keep this x as it is. On this side, A inverse into b, keep it as it is. Identity into x will be equal to x, and on this side, A inverse into b, keep it as it is. Means to find out matrix x, means to find out this matrix x, what are the element of matrix x? X and y. We have to solve this equation, means we have to find out value of x and y, values of the variable, which are called as solution of this equation. So to find out value of x, we will require what? A inverse. B is already known to us. This matrix is in which we have collected what? Constant term is matrix B. Means to find out x, we will require what? A inverse. So here, once this equation is known to us, our aim is to find out inverse of this matrix. Once the inverse is known to us, later on we are multiplying both sides of this equation first by A inverse. On this side we will get x. On this side, whatever may be the multiplication of these two matrices we are getting, then comparing these two matrices are what? Equal. And if two matrices are equal, corresponding elements are also equal, and element of this matrix are xy, means we will get the required values of xy. So let us apply this method to solve the example from our exercise. Now see the first example from exercise 2.3. In this case, two equations with two variables are given to us, and we are solving this equation applying inversion method. And second method to solve this equation is reduction method, which is very easy comparatively to what? Inversion method. Inversion method is also easy, but it will little bit lengthy comparatively to what? Reduction method. So first, in every method, either in inversion method or in reduction method, first we have to write down this equation in which form? Matrix form. And just now we have seen how to write down the equation in the matrix form. So already you will observe this equation, constant term are on the right hand side. So in this matrix we have to collect what? Variable. So which are the variable here? X and y. In the first row, write down the coefficient of x and y. Coefficient of x is here 1, coefficient of y is 2. On this side, write down constant term. Now observe the second equation. What is coefficient of x? 2, coefficient of y is 3, and on this side, write down constant term. In this way, we are writing the given equation in the matrix form. If you are writing given equation in the matrix form, you will get first mark. Now, once the equation is written in matrix form, then denote this matrix by A. So we are denoting the given matrix by, so first matrix by A, where element of this matrix are 1, 2, 2, 3. Denote this matrix by X, where its elements are X, Y, and denote this matrix by B. So here its element will become 2, 3. So therefore this equation will become, so first matrix we have denoted by A, this second matrix we have denoted by X, equal to, keep it as it is, this third matrix we have denoted by what? B. Whatever may be the equation we have got here, denote this equation by equation number first. Once this equation first is known to us, now our aim is to find out inverse of this matrix, and applying A inverse we are solving this example. That's why this method is called as inversion method. So now we are finding inverse of this matrix. So first consider this matrix. Consider matrix A, and element of this matrix are 1, 2, 2, 3. Now let us try to find out its inverse. Better, I am giving priority to find out its inverse applying row transformation. So in case of row transformation, we are applying which condition? That A into A inverse is equals to identity matrix. Write down the element of matrix A, where element of matrix are 1, 2, 2, 3. Then A inverse, keep it as it is. On this side, write down element of identity matrix 1, 0, 0, 1. Now to find out the inverse of this matrix, our aim is to convert this matrix into identity. And to convert it into identity, we are performing operation on row. And in case of row, if we are using row transformation, our first step is to convert this element of first column into 1, 0. Already 1 is there, we will require 0 here. And this is the element of R2, means our operation is on R2. And what is the element of R2 here? 2, from 2 we have to subtract 2, and whenever we are using addition or subtraction, we have to use corresponding element of any other row. So here we are using corresponding element of R1 and we are multiplying to R1 by 2 and we are taking subtraction, so that 2 minus 2 will become what? 0. So let us perform this operation on the element of second row. Keep element of first row as it is, 1, 2, A inverse also as it is. On this side also keep the element of first row 1, 0 as it is. So our operation is on R2 and we are multiplying to R1 by minus 2. Multiply by minus 2, here minus 1 into minus 2 is minus 2. Minus 2 plus 2 will become 0. Multiply here by minus 2, we will get minus 4. Minus 4 plus 3 will be equal to minus 1. Multiply by minus 2, 1 into minus 2 is minus 2. Minus 2 plus 0 is minus 2. Multiply by minus 2 will get 0. 0 plus 1 will be equal to what? 1. So next step is to get plus 1 here. That's why I'm multiplying to element of R2 by minus 1, isn't it? Multiply to the element of R1 by what? R2 by what? Minus 1. And using this minus 1, let us try to convert this element also into 0. So this is the element of R1. And if you will observe the element of R2 here, that is minus 1. If I am multiplying here by 2, we will get minus 2. Minus 2 plus 2 means we have to take what? Addition to convert this element into 0. So here we are performing two operations, one on R1 and another operation is on R2. Let us see what we will get if we are performing first operation on what? R1. So our operation is on R1, we are multiplying to R2 by 2. Multiply to R2 by 2, 2 into 0 is 0, 0 plus 1 is 1. Multiply by 2, 2 into minus 1 is minus 2, minus 2 plus 2 is 0. Multiply by 2, here we will get minus 4 plus 1 is minus 3. Then multiply by 2, 2 into 1 is 2, 2 plus 0 is 2. In this way, we have performed this operation on the element of R1. Now, this is simple operation, just simply we are multiplying to element of R2 by minus. So, multiply by minus 0, multiply by minus 1, multiply by minus we will get 2 and multiply by minus here we will get minus 1. Now, identity into A inverse will be equal to A inverse. A inverse will be equal to minus 3, 2, 2 minus 1. Once the inverse of the matrix is known to us, then consider the equation number. Consider this equation number first. So from equation first, what is equation first? A into x is equals to b. Then we are multiplying both sides of this equation by A inverse. So A inverse into AX is equal to A inverse into B. On this side, A into A inverse will become identity. X, keep it as it is. Here replace A inverse by its value, where element of A inverse are minus 3, 2, 2, minus 1. And element of matrix B are 2, 3. Element of matrix B are what? 2, 3. Now on this side, x into identity will be equal to x, and on the right hand side we are taking multiplication of these two matrices. We know that whenever we are taking multiplication, we are multiplying by row to the column. So multiply by first row to first column. So I am taking multiplication, parallelly we are taking performing calculation part also. Minus 3 into 2 is minus 6 and 2 into 3 is 6. Minus 6 plus 6 will be equal to 0. Now we are using element of second row, so here also we will get element of second row. So multiply by this second row to this column. 2 into 2 is 4 and minus 1 into 3 is minus 3. 4 minus 3 will be equal to 1. So therefore x means what? What are the element of matrix X? X, Y. And on this side, write down 0, 1 as it is. Here we can observe that these two matrices are what? Equal matrices. Since the matrices are equal, that's why we are able to apply the definition of equality. So therefore, by equality of two matrices, what is our conclusion? X will be equal to 0 and Y is equals to 1. And in this way, we have got our required value x and what? Y. if to check whether our answers are right or wrong, just substitute these values of x and y in the right hand side of this equation. If in the left hand side of this equation, if left hand side and right hand side becomes equal, means we can say that these are our required values, means required solution of the given equation. Replace x by 0, y by 1. So 0, and here 1 into 2 is 2, 0 plus 2 is 2. Yes, means first equation is satisfying. Let us check whether second equation is satisfying or not. Replace x by 0 and y by 1. So this term will become 0 and y 1 into 3 is 3. Yes, 0 plus 3 is 3, means both the equations are satisfying by this value. So we can say that our the values which you have got applying inversion method are right here. So again, let us revise this all the steps. First, whatever may be the equation is given to us, write down this equation in the matrix form. Once equations are written in the matrix form, denote first matrix by A, second matrix by X, third matrix by B. Now, whatever may be the matrix X, so here this matrix we have denoted by A, this by X, and this by what? B. So here we will get first equation. Then find out the inverse of this matrix, inverse of matrix A, by using any method, either reduction, either row transformation, column transformation, or adjoint. Once the inverse of the matrix is known to us, then again consider this equation number first, multiply to both the side of this equation by A inverse. On this side, A into A inverse is identity, identity into X is X, and on this side multiplication of A inverse and B will be a new matrix. So replace matrix X by its element, and element of this matrix X are nothing but variable, and later on applying definition of equality of two matrices, we will get our required values of variable, and this method is called as what? Inversion method. Now observe the example number second. In this example, two equations are given to us. First, we are writing this equation in the matrix form. Observe the first equation. What are the coefficient of xy? 1, 1. In the second matrix, as we know that we are collecting the variable, what is the constant term in the first equation is 4. Now observe the second equation. Here coefficient of x is 2, coefficient of y is -1, and on this side write down constant term. Means first aim is to write down the equation in the matrix form. Once the equations are written in the matrix form, denote the first matrix by A. So here its elements are 1, 1, 1, 1, 2, -1. Denote this matrix by X, its elements are xy, and denote this matrix by B. So therefore this equation will become, this matrix we have denoted by A, this matrix we have denoted by X, and this matrix we have denoted by what? B. So let us denote this equation by equation number first. This equation means this equation which you are denoted by equation number first. Just simply first matrix we have denoted by A, second by X, and third by B. Now our aim is to find out inverse of this matrix. So consider this matrix. So consider matrix A. And what are the element of matrix? 1, 1, 2, -1. Now we are converting this matrix into identity matrix, and here I am giving priority to apply row transformation method. Let us see what we'll get if we are applying row transformation method here. So if we are applying row transformation, so we are using which condition? That A into A inverse is equal to identity. A into A inverse is equals to identity. Write down the element of matrix where its elements are 1, 1, 2, -1. A inverse, keep it as it is. On this side write down the element of identity matrix 1, 0, 0, 1. Now we are trying to convert this matrix into identity, and since we are applying row transformation, so we are, what is first step? To convert this element of first column into 1, 0. Already 1 is there, only we are trying to convert this element into 0. So our operation is on R2, and we are subtracting 2 from 2. So to get 2 here, we are multiplying to R1 by 2, and we are taking subtraction. Let us perform this operation on the element of R2. Let us see what we will get here. Our operation is on R2, so on both the side keep the element of R1 as it is. So perform this operation on R2. These are the element of R2. We are using corresponding element of R1 and we are multiplying to R1 by -2. So multiply by -2. 1 into -2 is -2. -2 plus 2 is 0. Multiply by -2. 1 into -2 is -2. -2 minus 1 is -3. Multiply by -2. 0 in 1 into -2 is -2. -2 plus 0 is -2. And here multiply by -2. 0 into any number is 0. 0 plus 1 is 1. Now here we will require 1, and to get 1 here I am dividing to R2 by -3. Let us divide to the element of R2 by -3. See what we will get here. So A inverse, keep it as it is. Our operation is on R2, so keep element of R1 on both sides as it is. Just simply divide to the element of R2 by -3. So what we'll get here, 0 divided by -3 is 0. -3 upon -3 is 1. So here -2 upon -3 is 2 by 3 and 1 upon -3 is -1 by 3. Lastly, we have to convert this element into 0. So our operation is on R1, and if we are taking subtraction with R2 means R1 minus R2 will become what? 0. So after performing this operation on element of R1, we can say that our this matrix will become what? Identity matrix. A inverse, keep it as it is. Perform the same operation on this side also very carefully. 1 minus 2 by 3 is 1 by 3, and 0 minus means plus 1 by 3 is 1 by 3. So 2 by 3 minus 1 by 3, keep it as it is. On this side, identity into A inverse will be equal to A inverse, and here if we are taking 1 by 3 common from all the element, see what we'll get. 1, 1, 2 minus 1. In this way we have got the inverse of a matrix. Once the inverse is known to us, now next step is to consider which equation? Equation number first. So from equation first, what we will get? Ax is equals to b. Again we are considering this equation, and what we have seen, we have to multiply both sides by A inverse. So A inverse into Ax will be equal to A inverse into b. On this side, A into A inverse is identity. X, keep it as it is. Replace A inverse by matrix by its value 1 by 3 into what are the element of this matrix? 1, 1, 2, minus 1 into b, and element of matrix B are 4, 5. So element of this matrix are 4, 5. So on this side, identity into X will be equal to X. Keep this 1 by 3 as it is. Now simply we are taking multiplication of these two matrices. Whenever we are multiplying, we are taking multiplication of two matrices, we are multiplying by row to the column. Let us see what we will get here. 1 into 4 is 4 and 1 into 5 is 5. 4 plus 5 will be equal to 9. Now multiply by second row to this column. 2 into 4 is 8 and minus 1 into 5 is minus 5. 8 minus 5 will be equals to 3. So here at X I am replacing by matrix X. What are the element of matrix X? Will be XY. So what we'll get here, therefore XY is equals to. Now here easily we can observe that both the element of this matrix are divisible by 3. If I am dividing to 9 by 3, what will get here? 3. And if I am dividing to this 3 by 3, we will get 1. Now here we can observe that these two matrices are equal matrices. So we are able to apply the definition of equality of two matrices by equality of two matrices. What we will get? X will be equals to 3 and Y will be equal to 1. And in this way we have got our required values of X and Y. And let us check whether these values satisfies this equation or not. Addition of X and Y. X and Y should be 4. Yes, 3 plus 1 is 4. Means first equation is satisfying. Substitute X is equal to 3 and Y is equal to 1. So 3 into 2 is 6 and here Y is 1. 6 minus 1 will be 5. Means this value satisfies both the equation. So we can conclude that our answers are right here. In this way we have solved the given linear equation applying inversion method. Now see the question number Now see the question number 3. In this question also two equations are given to us. So first write down these equation in the matrix form. So observe the first equation, coefficient of x is 2, coefficient of y is what? 6. In the second matrix we are collecting the variable. On this side what is constant term? 8. Now observe the second equation, coefficient of x is 1, coefficient of y is 3 and constant term is what? 5. So we are denoting first matrix by x. Already we have seen this method in first two example. Denote this second matrix by x and this third matrix by what? B. So here we can observe that this matrix is A, this matrix is what? X is equal to, keep it as it is, and this matrix is B. Means after substituting these values in this equation we will get this equation. Means in short, first matrix is A, second matrix we are denoted by X and this matrix by B. So here denote this equation by equation number first. Now we are trying to find out inverse of this matrix, and to find out inverse we have three choices. Use either row transformation, column transformation or adjoint method. So first consider this matrix. So consider matrix A and element of this matrix are 2, 6, 1, 3. Let us try to find out inverse of this matrix by adjoint method. To find out inverse of matrix by adjoint method, our first step is to find out determinant of this matrix. So write down all the element of this matrix in determinant. So here 6 minus 6, what we are getting? 6 minus 6 is equal to 0, and if determinant is equal to 0, so we can say that matrix is what? Non-singular, and in case of non-singular matrix we can say that A inverse does not exist. This implies that A inverse does not exist, and since A inverse does not exist, that's why we can say that the solution of this equation also does not exist. Hence we can conclude that hence solution of given equation does not exist. So easily we can observe that here what is the ratio of coefficient of x? 2 upon 1 means 2, and ratio of coefficient of y means 6 upon 3 is also what? 2. So means if ratio of coefficient of x means a1 upon a2 and ratio of coefficient of y means b1 upon b2. If a1 upon a2 is equal to b1 upon b2, at that time we know that two lines are parallel, and linear equation in two variable always represent what? Straight line. And since these two straight line are parallel, we can say that there is no common solution, means there is no point of intersection. That's why we can say that solution does not exist. But this thing we have to prove using what? Matrix method, because we are studying this example in matrices, and question can also be asked using same method. Using matrix algebra, solve this equation. Means we have two choices, either use reduction method or use what? Inversion method. So in this way we have completed first three examples related with what? Inversion method in this question number first from this exercise. In the next video we will discuss last article from this chapter, that is solution of linear equation applying reduction method. If you think that these videos are very helpful to you, so like the videos and share these videos with your friends also.